Hi to everyone. MEM School of Engineering, Department of Mechanical Engineering, online class, subject mechatronics for final year students. Myself, Saravanan, Assistant Professor in Mechatronics. Unit number 4, PLC. Okay, last class we discussed about the introductions, ladder programs, then uh, control process of the PLC like that we discussed. So in this chapter 4, we discussed about logic functions and internal delays and internal relays like that we are going to discuss in the class. That is in this PLC we are using different logic functions. Already we know that AND or NOR, NAND and XOR with the switches. Okay, and normally closed condition, normally opened conditions like that we are going to discuss in this chapter. Okay, and first one, AND logic, that is done by the normally open switch, that is input A and in B. So then output, if both the input and the input B is enabled, then only output will be enabled. In OR logic, if input and any one of the input is enabled, the output will be enabled. In NOR gate, if both the inputs are 0, then only output will be there. In NAND gate, if any one of the input is 0, output will be there, because here they are using the normally closed relays use பண்ணிருக்காங்க. They are using the normally closed relays. In XOR condition, they are using 1 and 0. That means any one of the input is 1, the output will be available. Okay, there is a concept used in the XOR. Okay, and latching. So latching to hold a coil energize the input which recognize its cases, self-maintaining circuits, maintaining the state until the another input is received. It remembers its last state. Output is given as a contact or logic with the input contact. Output is released only when NC is energized. Example: running a motor latched with the start and stoppers, uh, normally closed. Then internal delay. So internal relay. So do not exist as real weight switching devices, merely bits in the storage memory to hold data behave in the same way as relays, being able to be switched on or off, switched other devices on or off. That is multiple inputs, multiple outputs, resetting latch, battery backup, master control relay, jump relay. So multiple inputs, so many inputs for single output. Example, barrier gate. Okay, we are using for so many input relay for the different outputs, and then multiple outputs for single input, that is IR1, IR2, like that we are using. That is only one switch we are using for controlling getting the different outputs, that is multiple outputs. Resetting latch, that is unlatching the output. Then battery backup, that is output controlled by internal relay remains energized even after power failure. Master control relay, to control large number of outputs, turn on or off whole section of ladder diagram. Jump relay, to perform a set of instruction if one condition is satisfied, if not do some other set of instruction. So timers behave like relays with the coils when energized, result in the closer opening of contacts after some preset time. So timers count fractions of seconds or second using the internal CPU clocks. So we know that the timer in mostly they are used in the different timing executions, like that. In washing machine, we are setting the time of to 80 seconds. How the computer is calculate the 80 seconds? It is generate the 80 time period between input and output. That is a square wave. It will generate the 80 square wave between the input and output. So after executing the 80 square waves, it will be executed. That is after 80 seconds. So this is the concept used in the timer. Okay. So that is how many pulses is generated, that is counted by the counter. Okay, so only most of the devices are done with the timers and counters in the common way. So different form of timers: delay on timer, delay off timer, on off cyclic timer, cascaded timer, sequencing timer. So delay on timer. So when your input is given, timer coil is activated. After preset time, a timer contact closes. So activates the output. Thus it delays input from reaching output, or output is delayed to happen. So delay of timer. So it is defined as when your input is given, output is activated, and also timer coil is activated after preset time. So timer contact normally closed to open. Sorry, normally contact open. It is contact deactivates the output. So that's it. Output is deactivated after preset time. So on off cyclic timer. When input is given, timer coil T1 is activated. After preset time, timer contact close, activate the output. So at the same time, timer coil T2 also is activated after preset time. So timer contact normally closed, its contact deactivates the output. So thus an output is activated for given preset value and deactivated for some other preset value. So next one is cascaded timer. The timer can have preset value from 0.1 second to 999 second. If the delay time exceeds 999 second, another time is needed for rest of the time. Example, if there is delay of 1200 second, it will be 1200 minus 999 is equal to 201. Hence, two timers, one with a 99 second, other time with the 201 second indeed. Sequencing time. Output may be activated after preset value of previous output being activated. That is, output 2 is activated after n second of output 1 activated. So delay between two outputs activated is n second. Example, a pump needed to be activated after motor is on, but with the time delay of n second from motor being on. Built-in elements in PLCs allow the number of occurrence of input signals to be counted. So items have to be counted as they pass along a conveyor belt, the number of revolutions of a shaft, perhaps the number of people passing through a door. A counter set of some preset number value. When this value of input pulse is received, so operates its contacts normally, open contact normally, closed contacts open. So form of counters, that is already know that up counter, down counter, up down counter with the mode of selections. We can use the same counter as a up counter or down counter. If up counter means initial value will be 0, if down counter means initial value will be some value. That is, for example, down counter means if you are using 15 means it will be count as 15, 14, 13, 12 like that. It will be convert. It will be count. So next is shift register. So register proof of internal delay. That is already you know that 4-bit or 8-bit or 16-bit data to be stored. Each internal relay effectively open or closed. States being designed as 0 and 1. So shift register, number of internal relays grouped together allow stored bits to be shifted from one relay to another. So three inputs. First to load data into the first location of the register. So second, command to shift data along by one location. So third to reset or clear data. That is 8-bit register with 8 internal relays. So data stored are given below. So first command is given to load input 0 into IR1. So second command is to shift. Hence every data moves by one location. So a data overflow out at the end. Each internal relay is connected to output. So accordingly, output activated if IR has 1 or deactivated if IR has 0. Okay. So this is the concept we discussed. We will see in the next class. Thank you.